Hey students, the first thing I'm going to do is I'm going to look at problem 8. Some of you had asked about problem 8, and it says, in Japan, farmers have created watermelons in the shape of rectangular prisms. Determine the volume of a prism-shaped watermelon in cubic inches if the length is 10 inches, its width is 2/3 of a foot, and its height is 9 inches. So in the problem, they have given us the length, the width, and the height. So they've given us all the things we need to find a rectangular prism, or the volume of a rectangular prism. I think the thing that people were having difficulty with was the fact that they wanted to change the 2/3 to a decimal to make it easier, and anytime you're working with thirds, that's going to be a repeating decimal. So it's really easier to leave it as a fraction. So we're going to write our formula. And then we're going to, I'm going to write length times width times height. And then I'm going to plug in what I know. And I know that the length is 10 inches. The width is 2/3. And the height is 9. So I'm going to go ahead and I'm going to work 10 times 9 and get 90. And then I'm going to multiply by 2/3. So I have to do 90 over 1. And then I can simplify that before I multiply. 3 divided by 3 is 1. 90 divided by 3 would be 30. And then I can multiply across. 30 times 2 would be 60. 1 times 1 is 1. 60 divided by 1 is 60. And that would be inches cubed. And that would be the volume. And this is for problem number 8. Okay? Now, moving on to problem number 9. Excuse me. Problem number 9, you've got the glass container. Shown is filled to a height of 2 25/100 inches. And it says how much sand is currently in the container. So basically what you're having to do is use this height and find the volume of the sand, okay? And so what I did was I wrote my formula. I plugged in the 5 which is here, which would be like your length. 4.5 would be your width. And then the 2 25/100 would be your height. And so I plugged all that in. I've got a decimal here, a mixed number here, a whole number here. So I need them all in the same form. So I changed my 4.5 to 4.5. And I had already multiplied my 5 times 2 25/100 and got 11 25/100. And so then when I multiplied that, I ended up getting 50 and 625,000 inches cubed. And that's just the volume of the sand in the container. Now the next question, part B, wants to know how much more sand could the container hold before it overflows? Well, if this is the height, then the height with the sand, this is the height of the whole container. So we could work our volume with the height of 3 inches, which is what I did right here. Did the same thing. I'm sorry, I didn't do the 3 inches. I did how much more could it hold. So I took the 3 inches and subtracted the 2 25/100, which gave me 7/500 as that part of the height. And then I found the volume using that. Okay, and there is that. The third part was what percent of the container is filled with sand. So what I did was I took the 2 25/100, that's the height of the sand. This is the height of the whole container, and I did percent over 100. And I solved it, and I found out that it's 75%. Over here, I did a model. Here's 100%. And I divided this into, first I divided it into what did I do? I did 3 parts, okay? So I did 1, 2, 3, right? 1, 2, 3. 1, 2, 3. Okay, that's not what I meant to do. Okay. Nope, I did that wrong. Sorry. Really, you should have divided it into 3 equal parts, which would have been here. Okay. That's 3 parts. Okay, so I did that because there were 3 inches. And so that means that each inch had, I divided it into fourths because I knew that this was 2 1/4. And so then when I found, let's see, the 3/4 would have been the 75%. Yeah. So that would have been 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is 2 25/100, which is 2 1/4. Okay. And so that means that is 75% filled. Okay. Little difficult here, but hopefully that will help you with problems 8 and 9. And I will see you guys today.